Right, so in this video, we shall look at some introduction to the more concept. This is the second video that we are looking at after we did the relative formula mass and relative molecular mass. All right, so let's get started. We are going to calculate the number of moles given the number of atoms. Now, what is the relationship between the number of moles and the number of atoms? So we are going to use this formula very much. Number of moles is equal to the amount, or rather, let's not use this. Okay, so let's use that for the number of particles over the Avogadro's constant. So this is the Avogadro is constant. Okay, then these are the number of particles. Number of particles. Now, these particles can be atoms, these can be molecules, or they can be ions. So these particles can be the atoms, molecules, or ions. You shall see how the questions are phrased. So just make sure that this formula, you understand it and you remember it always. Number of moles is equal to the number of particles over the Avogadro's constant. Now this Avogadro's constant, it is simply 6.023 times 10 to the power 23. Hopefully we are correct. This is the Avogadro's constant. Okay, so let's quickly do one or two examples and see how questions are asked. Okay. So we can say calculate the number of moles in the following. So let's have A in 1.76 times 10 to the power 20 atoms. All right, so let's quickly do some more concepts in this video. So all right, so hopefully you guys have already done the first lesson that we did, because if you don't have a better understanding in that one, it will be so difficult for you to proceed to what we are doing. All right, so more concept is very simple. It's very simple. Now, okay, the more. Okay, so we just established that the number of moles is equal to the number of particles over the Avogadro's constant. So we are saying this is number of moles. Then this is number of particles. Number of particles. This can be 1 atoms, 2, this can be molecules, 3, this can be ions. Then this is Avogadro's constant, which has a constant number of 6.023 times 10 to the power 23. Okay, so this is very important for us to understand. The number of moles is equal to the number of particles over the Avogadro's constant. Right. So make sure this formula, you be able to remember it. It's going to be very useful for us in our calculations. All right, let's do some examples so that this can make more sense. Okay, so number one, let's calculate the number of moles. Okay, so calculate the number of moles in a 1.76 times 10 to the power 20 atoms of calcium. B, calculate the 4.4 times 22 not atoms. Okay, molecules of carbon monoxide. Okay, so copy that question so that we quickly attempt to answer. Okay, so for part A, we have our x here is 1.76 times 10 to the power 20 atoms. Okay, so the guidance here is atoms because you said the number of particles, these can be molecules, they can be ions, or they can be atoms. So in this case, they said 1.76 times 10 to the power 20 atoms. So meaning that is the number of particles, the value of x. So the next thing that we need to do is, now they'll never mention the Avogadro's constant there. So we just have to know that if we have been given the number of particles, the relationship with the number of moles is using the number of particles over Avogadro's constant, which we know to say it is 6.023 times 10 to the power 23. This is the number of particles. Then the number of moles, which we are calculating for, we don't know. So we are going to introduce the formula. I'm sure you guys are able to remember that the number of moles is equal to the number of particles over the Avogadro's constant. So this is going to be number of particles is 1.76 times 10 to the power 20 atoms over 6.023 times 10 to the power 23 particles. So when we divide that, 1.76 20 everything divided by 6.23. Okay, so we are going to get the number of moles as 2.92213 times 10 to the power -4 moles. Okay. So what you needed to remember here is that since we have been given atoms, so meaning the X value in that formula we looked at is 1.76 times 10 to the power 20. Then since we have the number of particles, the formula we need to use is the number of moles is equal to the number of moles is equal to number of particles over the Avogadro's constant. This formula here, this is the formula we always have to use whenever we've been given the number of particles. Okay, we have been taught to say these are atoms. Okay, these are atoms. So if they said the number of molecules, we are still going to use this formula here. Say number of moles is equal to number of particles over the Avogadro's constant. So let's quickly look at the second example. Okay, so B was telling us that we had X was 4.4 times 10 to the power 22 molecules. So we have this word, molecules. Okay, so since we have the number of moles there, or rather, no, not the number of moles, but the number of molecules, we are simply going to use the same formula that we had. So here we are going to say Avogadro's constant is equal to 6.023 times 10 to the power 23 particles. Then we are looking for the number of moles. So the next thing here is to remember the formula. So we say number of moles is always going to be number of particles over the Avogadro's constant, which is going to be, in this case, we have X is 4.4 times 10 to the power 22 molecules over the Avogadro's constant, which is 6.023 times 10 to the power 23 particles. So if we punch in the calculator here, 4.4 k 22, everything divided by 6.023, multiplying that. So we have the number of moles as 0.0738532 moles. Okay, so this was our final answer. So just remember that whenever you have been given, it can be the number of molecules, the number of ions, the number of atoms, you are going to use n is equal to x over Na, this formula, where this is the number of moles and that is the number of particles, which is this. Then this one, it is always 6.023 times 10 to the power 23. All right, thank you so much, and hopefully you guys have gotten the concept. Check out for the next update, which will be the next concept to be talking about how to calculate the number of moles when you've been given the mass. And to calculate the number of the mass, you should have been given the number of moles. So don't miss that one.